Hi everyone, my name is John Wamboro. I am a PhD student at the University of Massachusetts Amherst. Today I'll be presenting our work titled Ride Substitution Using Electric Bike Sharing, Feasibility, Cost, and Carbon Analysis. I will start by looking at the background and the problem that we are trying to solve. And the first observation that we make here is that ride sharing has risen in popularity in the recent past. This is mainly due to its convenience. Now, originally, ride sharing came with a promise of reduced traffic and reduced carbon emission by reducing our reliance on privately owned cars. However, it has actually resulted in increased traffic. And research has also shown that ride sharing is up to 47% more carbon intensive than personal car trips. And this is mainly due to dead miles driven to a bigger passenger up. Now, at the same time, another form of ride sharing that has risen in popularity in the recent past is bike sharing, and particularly electric bike sharing. Now, an electric bike is a bike that provides pedal assist to the user using an inbuilt motor and battery. This makes biking easy and ideal for long and uphill rides. And since most taxi trips are short, they can easily be taken using electric bikes, which is a greener alternative, and this could potentially reduce carbon emission. Now, motivated by these observations, we ask the question, what are the costs and carbon benefits of encouraging more people to use bike sharing as a substitute for short car rides, for short car trips, and what is the feasibility of such an approach? Now, to help us answer these questions, we use three main data sets. The first one is the City Bike dataset from the City of New York, which consists of about 19 million trips taken in the 1 year period between July and June 2018-2019 by about 18,000 bikes spread across 941 stations. We also use about 354 million trips taken during the same time period by about 100,000 cars. We begin our analysis by looking at how feasible it is to substitute car trips using bikes. And we do this by looking at the distance of the trip, the pickup and drop-off locations, and the trip convenience. Now, looking at the distance, we find that the median taxi trip is actually quite short, only about 2.7 kilometers, which can easily be taken using a regular or electric bike. We also find that up to 70% of all taxi trips are within 200 meters of an existing bike station, which represents a walkable distance for a user to walk to the bike station as opposed to hailing a car. And finally, we find that for some trips, biking is actually faster than taking a car. And this presents an interesting alternative to users in some instances. Now, to determine which car rides should be substituted, we propose a linear optimization framework whose goal is to minimize the number of bikes required while also ensuring that the aggregate trip demand is met, including the substituted trips. It also ensures that short rides are taken using regular bikes, while longer trips are taken using electric bikes, and median distance trips are taken using either type of bike, depending on whichever is available at the start of the trip. We apply our linear optimization framework to our data sets, and here are some results. In the first set of results, we find that we require about 10,000 bikes to substitute 1% of all car trips. And this is about 30% more than a homogeneous system, which would use only one type of bike. And the higher number of required bikes in the hybrid system is due to the convenience introduced by taking a different bike depending on the nature of the trip. We also find that doubling the number of trips leads to only 52% bikes more being required to substitute the trips. And this is a sublinear increase in the number of required bikes with an increase in the number of substituted trips, which is an interesting observation because we only require a modest investment in bikes to substitute even more car trips. And finally, we also show that up to 6.6% of all carbon emission can be eliminated with 10% trip substitution. Our paper contains a lot more results, and I encourage you to go read it. But in summary, we show that car rides are easily substitutable with bike trips. This is owing to their short distance. And also the fact that most car rides are within walkable distance of an existing bike station. We also show that the number of bikes required increases sublinearly with the number of substituted rides. And this is an interesting observation because we do not require a huge investment to substitute even more car trips. And finally, if implemented, we show that ride substitution can lead to significant carbon reduction. Thanks for listening.